Today we're going to be talking about the different kinds of things that happen within meteorology. We're going to be going over the different type of fronts a weather system has, different types of precipitation, and we're also going to be talking about airlifting and the different kinds of those. So here we're talking about a cold front. There's a picture to show kind of visual of what's happening, but via the book it says when a dense cold air is actively advancing into a region occupied by warmer air, the boundary is called a cold front. We all kind of know what those are. Just think of having a normal nice day, warmer weathers, and all of a sudden just getting a big storm of cold weather to come through, and it kind of mixes and hits into each other, and that's what brings in the cold front, overbearing the warmer temperatures. So opposite of the cold front, we have the warm front. Here's our picture on the side kind of showing what it is. As the book says, when the surface position of a front moves so that the warm air occupies territory formerly covered by cooler air, it's called warm front. So basically just think of warmer air overcoming cold air, and it's replacing the cooler air of that surface. As we know what things are when they're stationary, it means they stay in one spot. So a stationary front is going to basically be where the warm air and the cold air aren't really necessarily mixing. They're most likely going parallel of each other from the line of the front. So they're just staying in one area. So a stationary front is a position in which it does not move. So an occlude front is going to be one that demonstrates cold fronts moving faster than the warm fronts. So they tend to catch up to and overtake their related warm front. So basically what's happening is the cold front's going to move faster and it's going to kind of overcome the warm air, therefore making the occluded front. So precipitation as a whole is basically a weather condition where something is falling down from the sky. So what we're going to be looking at is the chemical reactions that happen with usually water, and how it transitions through different stages and different consistencies as itself. So it's going to be through more of a solid or a liquid or maybe even gas. So we're going to be talking about how it develops within the clouds and how the water vapor begins to form into how the atmosphere cools and condenses the minerals and things like that. So when we're talking about the precipitation of rain, we're going to be talking about how it develops when growing cloud droplets because it's too heavy to remain in the clouds, so they become too heavy within the clouds so that they fall, and they usually formulate in cumulonimbus clouds, which are rain/storm clouds. So one thing I learned actually was that raindrops tend to not actually look like teardrops like they do in movies and cartoons. They're actually very spherical, and that's how they fall as well. So when we're talking about the precipitation of snow, we're basically going to be focusing on the fact that ice crystals that formulate in these clouds and continue to fall, they connect to each other as they fall, and then because they connect, they grow as kind of like its structure of snow. So the lower the temperature, the fluffier the snow due to low humidity. So the less humidity there is, think about how if there's more water in the air, then it can become more condensed, making it a little bit more watery, whereas less water in the air makes it fluffier and a lot more dry kind of snow. So hail is something that usually formulates during thunderstorms. So it kind of starts off as snowflakes, and as they fall, liquid water freezes onto them, forming the ice pellets that continue to grow as they fall. So then as they kind of get closer and closer to the ground, they're formulating all these different liquid water that's freezing onto it. So that's creating those ice pellets, and they're getting bigger and bigger as they come down. So they're usually produced by cumulonimbus clouds, and the updraft can reach up to a speed of 100 miles per hour. So with sleet, as we all know, sleet's not anything fun to walk, ride, or drive on in any of those ways, shapes, or form because it is basically just frozen water or frozen rain that is falling onto the ground and staying there. So in order to be produced, a layer of air with temperatures above freezing must overlay a sub-freezing layer near the ground. So when raindrops leave warmer air, as they come down to the ground, they're going through a colder air below, and they freeze, and they cover the ground with small ice pellets. And that's what creates that slick, icy kind of feeling as we drive, walk, or whatever, and slip and fall technically on the sleet. So when it comes to airlifting, we have multiple types, but the two types I'm going to be going over is the orographic, and the frontal lifting. So orographic acts as a barrier to the flow of air, making the air rise. So usually we see that with mountain ranges, the mountain ranges acting as that barrier to the flow of air. The frontal lifting happens when warm air glides over colder air, so it represents the leading edge of warm air to cold air. So it's going to be that kind of cold front versus warm front frontal lifting.